Hello everybody, this is Rudra Pradhan here. Welcome to Engineering Econometrics, that to the coverage on time series modeling. We have already discussed various time series models and various mechanisms through which you can receive the estimated model, and then we check the reliability, validity and stability by using various time series indicators such as mean error, mean square error, root mean square error, mean absolute deviations, mean absolute percentage error. So, that means we have actually various alternatives indicators through which you can check the reliability, check the validity of the estimated models, and then do the predictions as per the particular requirement. So, now to extend these lines of discussions, we will see what are the other ways we can do the similar kind of structuring and restructuring, and through which you can actually receive the best models as per the particular requirement and the kind of need in the industry or any kind of organization. Okay. So, by the way, we have already discussed various forms of time series model, and in this lecture we specifically highlight a component called as ARIMA cluster, and it is also one kind of forecasted model through which you can do the forecasting. Again, we start with a single variable and then we create a kind of estimated structure through which you can do the prediction of the same variables. So, now ARIMA is a kind of structure through which you can do the similar kind of forecasting. So, ARIMA stands for Autoregressive Integrated Moving Average, and here we have two different structure. One is the autoregressive structure and the second one is the moving average structure. So, now the issue is here, first you can have a actual y and then we may have a predicted y. After having the predicted, then you will get the error component, which is the difference between the actual and the estimated. Now, once you get the error term, through the error terms we can create the kind of different models. There are two types of such models. So, one case you have to just connect with the y t with the error terms, then another case y t with the lag of these y t's. For instance, y t equal to y t minus 1, y t minus 2 and so on, and that is the difference between these two, that is moving average modeling and autoregressive modeling. And then if you connect, then that becomes called as ARMA models. Then in between there is a component called as a integration, that is the actually term called as order of integration. We technically in the time series angle called as stationarity of that particular variable, and there are a couple of techniques are there to check the stationarity, and in time series analysis again this particular component we call as unity root. So, now you like to check the unity root, that means the objective is to check what is the order of integration through which the variables becomes stationarity, reaches stationary. So, that means stationary means it is in normal conditions, but usual behavior of time series variable in original form is not is basically non stationary. That means there is a huge volatile and imbalance, but we like to know at what level the particular variable will be in a kind of stable form or balancing form, and the way we will bring that that is what the process called as unit root check or stationarity check. Then after knowing the stationarity of a particular variable, that means the order of integration through which the variable can reach the stationarity, then you can use ARIMA clusters, then VAR clusters, then volatility clusters. So, these are all actually three different clusters of time series modeling. So, in this lecture specifically we highlight the ARIMA clusters, that to autoregressive structure and moving average structure, and the procedure through which you can have this model is that first we have actual, then the estimated, and then we find out the error terms, and then start with integrating with log of these error terms and log of the original variables. So, how many log of the actual variable and how many log of the error terms should be there, that is the kind of question mark, and we have two procedures for that. In the first procedure, we like to know what is the order of integration through which the variable reaching the stationarity, and the second case, how many such log variables can be finally used, so that we can do the prediction perfectly as per the particular engineering requirement. So, that means technically we have two different requirements here that need to be tested first or that need to be evaluated first, that is the order of integrations, that to the stationarity check, and the second one is the log length. So, we need optimum log length through which the model can be used as a indicator through which you do the forecasting. Of course, while checking the unit root test, we also use the optimum log concept, and then we can go for the autoregressive schemes or moving average schemes or the joint one, the autoregressive and moving average scheme. In fact, the stationarity check and the kind of order of integrations are somewhat mandatory requirements for ARIMA cluster, volatility cluster and VAR clusters. So, until unless you know the order of integrations, you cannot just analyze the ARIMA structure, you cannot just analyze the volatility cluster and then the VAR cluster. So, let us see how is this ARIMA cluster. So, basically it is the game of trend analysis, and again we start with the trend analysis, autoregressive model, moving average models, and then the kind of clubbing, that is the ARMA models, autoregressive moving average model. So, again these are the same forecasted errors are used, like mean error, mean absolute deviation, mean absolute percentage error or mean square error, root mean square error. So, again same indicators are used to validate the structure. In fact, here it is the kind of examples y and x, where y is a dependent variable, x is independent variable, then you find out the estimated line, then find out the error terms. That is the game against one way to check the validations, but what we are discussing here in the trend analysis, the same variables can be integrated with its log variable only, and that is what the beauty of this particular scheme. And here least square can be used as a mechanism to have the estimated figure, and again this is the actual and this is what the independent variables. So, we can have the forecasted value and then error value, and again we go for checking the reliability and stability of these forecasted figures by checking the mean error, mean absolute error and mean square error, root mean square error and so on. So, here in the trend analysis, by default you will have actually actual facts and actual observations, that is what the blue one, and then the predicted one, that is the black one, which is slightly linear kind of things, and the actual is slightly nonlinear kind of things. That means, it is not so straight, and the mechanisms through which we use trend and the kind of forecasting procedure, that we need actually a trend line through which actually you can visualize and do the prediction perfectly as per the particular requirement. So, now the kind of least square mechanisms can be used to do the forecasting. So, that is what with respect to two variables, and same OLS mechanisms can be used to minimize the structure and to have these parameters, and then we have the estimated model. So, now what is happening here, we are just doing y and x, and here this will just interchange while doing the time series. Instead of x, we can put yt minus 1, then you have the similar kind of structure and get the trend line. Again, so if you are connecting with it say x and x square, Now, in the time series setups you can have yt minus 1 and yt minus 2. So, in that case you have 3 parameters, and as a result you have a 3 different equation, and then if you simplify, you will by default you will get the parameters value a, b, c, and that will be used as a indicator through which you can do the forecasting. Now, after knowing this kind of trend structure, we can move into the autoregressive scheme. Here means first instance you should have estimated estimated equations. That's what the structure we call as y and y head, right. So, that's here y head, and then we can have y means y and y head, and technically y head is the estimated one, and then we have y. So, the difference by default will give you the error component. So, now what is happening actually, before you go for estimated one, to get the error terms again integrated with the actual y, and you first check what is the estimated y. For that it depends upon so many lag variables yt minus 1, yt minus 2 and up to yt minus p, and again if you simplify, the model can be transferred into this form. So, where mu is the intercept, and then these are the coefficients against the lag variables. When I equal to 1, then this is actually yt minus 1, when I equal to 2, this will be yt minus 2 and so on up to yt minus p. Now, the question is whether you will restrict the model up to this, or whether you will restrict the model up to this, or whether you will restrict the model up to this. So, that means it can be a simple bivariate, it can be simple trivariate, or it can be simple kind of multivariate in nature. So, so issue is actually how many lag variables ultimately you can use, so that the model will be very perfect for the prediction and forecasting. That is the big deal in the case of ARIMA models, and we are discussing here autoregressive scheme. So, the difference between autoregressive scheme and that moving average is that, so the actual y will be connected with the lag of that y, and that is the form called as autoregressive structure. When you are connecting yt with the error terms, then this becomes a moving average scheme. In the case of moving average scheme, so first you estimate the model, get the error term, then against the new model will be yt versus the error terms. Then you check how best, how good, or how best we can pick up the things. So, now ultimately, so this is the general framework of autoregressive model, and then the counterpart will be moving average models. So, in that case you have this scheme here, yt equal to ut minus 1, ut minus 2, ut minus q. So, here you see yt as a function of yt minus I technically, and here y equal to yt equal to function means yt as a function of ui or ut minus I. So, when I equal to 0, then it becomes ut, and when I equal to 1, then it becomes ut minus 1, but it is the game called as error terms. But technically the framework is like this. So, you have yt, then yt head, then error terms, which is the difference between yt and yt head, that is the estimated, and how to get the estimated, that depends upon the kind of lag structures, and then you have ut, and you can create ut minus 1, ut minus 2 and so on. So, that means we have a couple of derived variables. Now, after getting error terms, so you can omit this one. So, then the new estimation process will be yt upon ut, again ut minus 1 and ut minus 2. That is what we have here actually, and in this case the structure is called as moving average. So, in the case of autoregressive, it is the actual variable with its lag integration, and in the case of moving average, the actual variable, that is yt with the error component and the error lags. So, that is what the kind of structuring. So, now again the question is how many such lags you can use for this moving average. So, now in one case we have here the kind of what we can call as a the autoregressive, and then here the issue is actually optimum lag length, and again in the case of moving average there is also question of optimum lag. Then now what will we do? We will just club these two, autoregressive scheme and moving average scheme, and we will have a single component, and that single component is called as ARMA. Of course, this is what the ARMA clusters. Okay, this is what the ARMA cluster, and what is happening here? What is happening here? So, you will just integrate with the yt with the log of the yt and then log of the error term. So, that means we have scheme called as ARMA 1 then ARMA 2 and so on, like this, ARMA 3 like this, right. So, that means technically you see here, if it is 1 then that means yt minus 1 and then ut minus 1, then 2 means yt minus 1, yt minus 2, then ut minus 1, ut minus 2. So, when ARMA 3 then yt minus 1, yt minus 2, yt minus 3, then ut minus 1, ut minus 2 and ut minus 3. So, that is what the linkage is all about. So, likewise you can go go on adding one after another y log and the error log. So, ultimately you start with a single variable yt, and then we have a plenty of log yt, again we derive a error component and create n number of log of the error term, and then you are integrating yt with log of this yt and then the log of the error terms. Then finally, you have this system through which you actually you do the predictions and do the forecasting, and and you check the reliability and stability by using these indicators like against mean error, mean absolute percentage error, mean square error, root mean square error. So, that means various ways of getting the estimated equation, and then check the reliability stability before you use this model for any kind of engineering predictions and the kind of requirement. Of course, we can check the reliability by taking the clue of mean of the error term should be equal to 0 like this here, then variance of the error term should be equal to sigma square, and if the variance of the error term is not sigma square, that is what the term technically called as homoscedasticity, and if the error variance is not same, then we call as heteroscedasticity, and then cross correlation, that is what the term called as autocorrelation, that should be also not there, that is called as 0. Of course, once you get the error term, this should be satisfied before you integrate the yt with log yt and the log ut. So, once it is clear, then you can proceed for the kind of extension, and then use the extended model for the kind of predictions and the kind of forecasting. Of course, we have discussed specifically autoregressive scheme, then moving average schemes, then ARMA scheme. So, that means altogether we have 3 different clusters altogether, that is under the ARIMA cluster. Autoregressive cluster 1, then moving average is the second, and then autoregressive moving average is the third. Every time the I is an instrument that to check the order of integration through which the particular variable reaches the stationarity. Here the stationarity can be checked the y variables, then yt minus 1, then error component. So, whatever variables would be finally used in this particular estimation process, all the variables are individually tested the order of integration through which it reaches the stationarity. And of course, one of the most important issues is the log specifications. We need a optimum log length through which you actually get the best estimated model through which you do the prediction and forecasting. So, that means optimum log length is the criteria through which you can reach the target and reach the destiny, and we have a couple of again criteria through which actually you can fix the optimum log length, that is the AIC statistics and then the SIC statistics, Eka information criteria and Schwarz information criteria, and basically this criteria exclusively depends upon three components, the item called as K and the N stands for sample size, and then K stands for number of variables. If it is moving average, then YT with how many lag, and then if it is moving average, then YT with how many lag UT. Again under ARMA, YT with how many lag YT and how many lag UT. Ultimately, that means we want to know whether the structure is 1 or 2 or 3 like this. What one particular cluster will be uniquely deciding factor to do the forecasting. Not of course, mathematically we have n number of clusters, but technically only one cluster which can give you better result. Every times we again use these indicators are the tool to find out the best one, whether it is 1 or 2 or 3, and then we will use that model for the kind of forecasting and the kind of requirement. So, here the issue is that like mean error, root mean square error, mean absolute percentage error, or kind of mean absolute deviation. So, every times the comparison is that where these parameters are having low value compared to the previous one, that model will be used for the kind of final prediction. So, the same criteria will be used here while choosing the optimum log length. So, you start with 1, then you have a model, and then again 2 we have a model, whether it is a autoregressive scheme separately or moving average scheme separately or together, that is what called as ARMA. So, you can start with the, if it is say autoregressive, then the structure will be restricted with the 1 only, that times YT, YT minus 1 and so on. So, every time it will go with 1, then again moving average. So, it is again means the moving average case, this will be silent and this will be changing, and then in the case of autoregressive this will be remain silent and this will be changing, and again ARMA cluster both will change simultaneously. And technically whether to stop here in the case of 1, whether to stop 2 or whether to stop 3. So, that is exclusively depends upon the AIC value and SIC value. So, that means technically you may have 3 different models altogether. In one case we have 1 scheme, then have the estimated models, and then you find out the AIC statistics, then 2 have the estimated model outcome, and then AIC statistics, then again 3 must have estimated model, and then have the AIC statistic. Now, you have 3 options, and out of these 3 options where the AIC statistic will be lower one, and that will be the final choice. So, the way we will choose the best one through AIC, SIC also having the similar kind of testing procedure and similar kind of evidence. If for instance, out of these 3 1 2 3, if AIC say through the means, that means on the basis of AIC, if we find 2 scheme is the best one out of 1 2 and 3. So, this SIC statistic will also give similar kind of inference, where 2 is the best ones out of 1 2 and 3. So, so we must know the model selection criteria, that to the choice of optimum log length, and then again you should know the model validation indicator or stability indicator, starting with mean error to mean absolute percentage error and root mean square error, and every time as the criteria is actually to pick up the models which have actually lower of these means lower values of these indicators, that against that is either AIC statistic or SIC statistic or any other time series validation indicator starting with mean error and then root mean square error or something like that. So, ultimately we have discussed various forms of models through which actually we can actually go for the kind of forecasting and then the kind of engineering requirement. So, ultimately so we have various time series setups through which you can have the estimated models and then use the estimator for the prediction and forecasting. Means in the software you just enter the data and then there are a couple of softwares by default if you connect with the ARIMA, and then you have to just fix the order 1 1 or 2 2 or 3 3, then by default you will get various estimated output. That is in a kind of simulation process you just change the structure, then run the models, you will get different levels of output. And if the standard software is not there like eViews or Stata or something like that, then still you can do in the Excel sheet just to have yt, then create yt minus 1 first and then again link with yt yt minus 1s and have the estimated model and get the error terms. Then after that you can create yt minus 2, yt minus 3, yt minus 4, just extend this existing yt minus from the yt minus 1, and then you just get the error terms which is actually difference between yt and yt minus 1, and then again you create ut and log ut minus 1, log ut minus 2, ut minus 3 and so on. Then finally, if you say 1 1, then definitely the dependent variable will be every times yt. Then if it is 1 1, then you have to give means in the data analysis you have to give indication about the yt minus 1 and ut minus 1, then run the model. So, then you will have the estimated model with respect to yt minus 1 and ut minus 1. Then again if for 2 2 scheme the same yt will be the dependent variable, and then yt minus 1, yt minus 2 and ut minus 1, ut minus 2 are the independent variables, and again run the models, you will find the results under the scheme of 2 2, and then finally under the scheme 3 3 same yt will be the dependent variables. Then you start with the independent variables like yt minus 1, yt minus 2, yt minus 3, then ut minus 1, ut minus 2, ut minus 3, and then run the models, you will get the estimated outcomes, and that too for the scheme of 3 into 3. So, that means actually when you will start moving from 1 1 2 2 2 and then 3 3 so on, then every time the model will start simple moving from simple to complex, and where the parameters value will be start increasing. So, when the parameters value will be start increasing, then definitely the significance of these parameters may be getting affected, because the degree of freedom will be less and less when the parameters will start increase. That means, if you start with 1 1 2 2 movement from 1 1 to 2 2 and 2 2 to 3 3 and so on. So, every time the number of parameters in the estimation process will be very high, and when number of parameters are high to test and then the sample size is remain constant. So, that means, in a given format, so if you start with 1 1 2 2 3 3, the sample every time is constant for the particular problem. Then what is actually major problem is that the parameters are different from 1 1 to 3 3. So, the means different means it will be having increasing numbers. So, given the sample size and increasing number of parameter to test, by default the degree of freedom is less, and there is high chance that the particular variables may not be statistically significant. So, so there is a need of justification here to pick up the optimum log length. So, that means choosing optimum log length technically means you are fixing the variables, number of variables to be used or to be included in the system through which the particular engineering problem can be analyzed properly without any issue or without any conflicts or without any kind of defects. So, so we have discussed various types of time series models to do this kind of forecastings, and after this ARIMA clusters we have two different more schemes, that the volatility modeling and then the VAR modeling. So, in the next lectures we will start with the volatility modeling first, and then we will go for VAR modeling, and then we will go to other forms of modeling like panel data modeling and the count data modeling and so on. With this we will stop here today. Thank you very much. Have a nice day.